In part 3 of our seminar, we're going to look at two theorems here that we're going to use mostly algebraic. They might show up in a proof here and there, but here's what it is. If we look at slopes of parallel lines, this one should make intuitive sense. Since lines are parallel, their rise and run have to be the same. So if you have parallel lines, they're going to be equal. The only time they won't be equal is if you have vertical lines, because they'd both be undefined, but they'd both be vertical lines. So they have the same slope. If they're perpendicular, what's happening is you're doing a rotation of that by 90 degrees. Since you're doing a rotation of 90 degrees, the x and y switch, and the y becomes negative, so they are opposite reciprocals. So your two lines have negative reciprocals for slopes. If they're not the same and they're not negative reciprocals, they're not parallel or perpendicular. They'll be something neither. Let's take a look at example 5 here. I want to determine whether FG and HJ are parallel, perpendicular, or neither. Well, let's find the slope of FG. Remember, slope is y2 minus y1 over x2 minus x1. So I'll label those x and y. Notice we do not subtract in the same ordered pair. We subtract the y's in each one. The order doesn't matter. Since g comes second, I'm going to call that my second point. So I'm going to say -1 minus a -3, which is -1 plus 3, over -2 minus 1. -1 plus 3 is -2. -2 minus 1 is -3. So a negative divided by negative is a positive. So the slope of FG is 2/3. Now let's turn around and let's find the slope of HJ. I'm not going to write down the formula because I already wrote it down, but we're going to do the same thing. X, Y, X, Y. So I'm going to say 3 minus 0 over 6 minus 5. Well, 3 minus 0 is 3. 6 minus 5 is 1. Notice my slopes are neither parallel nor perpendicular, so we're going to say neither. On example 6, let's pause the video and see if you can do that one yourself. So we're kind of doing the same thing we did in example 5. I got line AB and line CD. I want to know if they're parallel, they're perpendicular, or they're neither. I'm going to blow this up here, and then I'm going to write in what X and Y are in each one, because I don't want you getting confused there. So it goes X, Y, X, Y, X, Y, and XY. Now, let's find the slope of AB. So AB, if we're doing slope, it's y2 minus y1 over x2 minus x1. So 5 minus a -1 over 4 minus a -2. When you subtract a negative, we add. So 5 plus 1 is 6. 4 plus 2 is 6. 6 divided by 6 is 1. Let's turn around and let's find the slope of C to D. So we're going to say -2 minus 1 over 9 minus 6. Well, -2 minus 1 is -3. 9 minus 6 is +3. They're not the same, so they're not parallel. The reciprocal of 1 is 1. So if you flip 1, you get 1. And notice they're opposite signs. These are negative reciprocals of each other. So therefore, we're going to say these two lines are perpendicular. Continuing on to example 7, it says A plan for a railroad shows a straight section of track along the line y equals 1/5 x plus 2. A second straight section of track is perpendicular. I'm going to highlight that. That's important. Is perpendicular to the first and passes through the point 2, 0. Write an equation in slope-intercept form for the second section of track. Well, we know from our equation the slope of my first equation is 1/5. Well, since the slope is 1/5, when I look at the perpendicular slope, notice I don't use the 2 at all. I'm just looking at the slope, because in slope-intercept form, 1/5 is your slope. That would be -5 over 1. Now, it tells us to write the equation in slope-intercept form, but we have the slope and we have the point. So although it says write in slope-intercept form, I'm going to start by writing in point-slope form. So I'm going to say y minus y1 equals m times x minus x1. Let's substitute what we know in. So we're going to say y minus 0 equals our slope, which is -5, times x minus 2. We get the 2 and the 0 from x sub 1 and y sub 1 from our point. Now let's simplify. Well, y minus 0 is y. Distribute that -5 inside. You got -5x plus 10. There's the equation of your second track. You got to be nerdy if you're going to write the equation of your railroad track in a model railroad, but that's what it is. Or maybe an engineer might do that when they're planning it out or typing that into their AutoCAD. Okay, example 8, I suggest let's pause the video and see if you can do that one by yourself. So we want to write an equation in slope-intercept form for the line perpendicular to the line y equals 1/3 x plus 2, and it passes to the point 0, 8. Well, we'll start here with like the last one. We know the slope is 1/3. So if my slope is 1/3, what's the slope of the perpendicular line? Well, that would be the negative reciprocal or opposite reciprocal of 1/3. So that would be -3. Notice they told us the y-intercept. I can write this in slope-intercept form straight up. So y equals mx plus b. Since x is 0, that's my y-intercept. So I'm just going to replace m and b in my equation. So y equals, my slope is -3x. My y-intercept is 8. So -3x plus 8 would be choice A in this multiple choice problem.